Okay, so now we're going to talk about thiols and sulfides. And like I said, we're not really going to go into quite as much about these compounds as we did with ethers and epoxides. One thing I want to make sure everybody's got is nomenclature. That's going to be the big one here. We'll talk a little bit about reactions, but it's largely a review of what we've already done. Okay, so if you remember back to functional groups, when we were talking about functional groups, molecules that have this SH are called thiols. Okay, thiols are very similar to alcohols. If you look on the periodic table, oxygen and sulfur are right on top of each other, right? So oxygen's the smaller one, and then you have sulfur right underneath, meaning that they both like to have two bonds. And so a thiol group and an alcohol group are very similar. And we name them fairly similarly as well. But instead of having the ending "-ol, we use the ending thiol. The other big change, and who knows why, but the other big thing is that instead of being like, for example, this is butanol, we use butane thiol. You don't actually drop the E off of the end, okay? So these would be example, right? So these are two very similars. I'm just replacing the OH group with an SH group, 3-methyl-1-butanol versus 3-methyl-1-butane thiol. And then if you have two of them, it would be a dithiol. So this would be an example of 2,2-butane dithiol. And then thiols are also called mercaptans. And let's sort of see why that, or see how this plays into our nomenclature. Now we got to go back to this priority table that we sort of introduced at first, or introduced first last chapter. So again, this has to do with every functional group. Organic chemists around the world got together and ranked each functional group in terms of priority. And when you have multiple functional groups in your molecule, then you want to create your parent chain such that it includes them all. Where priority comes in is this idea that the highest priority functional group is going to get the lowest number. So we saw this with alcohols. When we had this mixture of an alcohol and an alkene, we kind of ignored the alkene portion when we were doing our numbering, other than to make sure it was included in the parent chain, but we really made sure that that alcohol group had the lowest number. Same here. So notice that alcohol above thiols. So now this is going to be this added layer to priority that's going to be really important. When we have just a thiol all by itself, right? Something like this. This would be propane thiol, right? It's actually one propane thiol. We use the suffix thiol, okay? When we have both an alcohol and a thiol group in there, we're going to refer to the higher priority group by its suffix and the lower priority group by its prefix. Okay, so just by sticking now, giving this same molecule, but sticking this alcohol group on there. Now I have two functional groups, right? So this is sort of the thought process you're going to go through. I have two functional groups. This one is the higher priority. So that means I'm going to start numbering to give that the lowest possible number. So this would then be 1, 2, 3. So then it's going to be a propanol. The alcohol group is located at carbon 1, but then how I'm going to refer to this thiol group is with a prefix of mercapto, because it's no longer the highest priority group. If it's the highest priority group, you refer to it by its suffix. If it's not the highest priority group, you refer to it by its prefix. So this would be 3-mercapto, 1-propanol. Okay. Notice that we have this hydroxy prefix as well for when we have something that's a higher priority group than an alcohol. To see anything this semester that's a higher priority than an alcohol. So this will become important later, but this prefix doesn't matter right now. Okay, just note, we're going to talk about higher priority groups next semester. For this semester, you're only going to ever refer to alcohols by the "-ol suffix. But for thiols, if it's the highest priority group, you will call it as a thiol suffix. If it's not the highest priority group, that's when you have the mercapto prefix. Okay, so let's see some other examples. So again, here, my highest priority group is just that thiol group. I number in such a way that at the lowest number, so I get 2-methyl 2-butane thiol. When I have both a thiol and an alcohol functional group, the alcohol functional group is higher. So I'm going to number it in such a way that it gets the lowest possible number. So this would be a 1-butanol. That refers to this portion here. I got my methyl group off of carbon 3. So 3-methyl. But importantly now, I'm going to refer to this SH, this thiol group, by its suffix prefix mercapto. So this is 3-mercapto, 3-methyl, 1-butanol. Okay. Again, you're going to arrange them in alphabetical order. This isn't like the epoxides thing where it always goes before the parent. Mercapto goes before methyl because it's alphabetically before methyl. Okay. Likewise, down here, this has this common name, dimercaptol. Who knows? But in terms of the systematic name, I have an alcohol group as well as my thiol groups. This is the higher priority. So I'm going to number to give that the lowest possible number. So it's a 1-propanol. That refers to this here. And then the other two groups, because they're no longer the highest priority group, I'm going to refer to it by the prefix mercapto. I got 2 of them, so it's actually 2,3-dimercapto, 1-propanol. Okay, apparently this is used to treat mercury poisoning. Who knows? Okay. Thiols. So thiols in general are known for kind of like having an unpleasant odor. Skunk's defense mechanism are thiols. If you've ever eaten asparagus, you have the rather smelly incident afterwards. That's also sulfur-containing compounds. Garlic's got a lot of sulfur-containing compounds as its active ingredients. They tend to have, maybe not unpleasant, garlic smells great. Strong odors, though. The sulfur-containing compounds tend to have stronger odors. What we learned about these sulfurs, in particular, whether it's Rs minus or the hydrosulfide ion, they are strong nucleophiles, but weak bases. That kind of unique category where they don't promote elimination reactions, but they are very good at substitution reactions. So in terms of how we create thiols, we would use hydrosulfide ion, and in the presence of, for example, an alkyl halide, which readily undergoes substitution reaction, we would see that. But even if we had a secondary alkyl halide, which we know can prefer elimination under certain circumstances, because the hydrosulfide ion is such a bad base, it will also promote substitution type reactions, right? And these are going to be SN2, so that's why we see this inversion of our stereochemistry. All right, so in the same way that thiols are analogous to alcohols, sulfides are analogous to ethers. Okay, so this would be diethyl ether. Just for practice, if we want to do the IUPAC name, we would have 1, 2, so this would be an ethane, and this functional group here would be an ethoxyethane. So then in sulfides, in terms of the common names, same sort of idea, put the 2 groups followed by the word sulfide. That would be the common name for those. But again, notice just analogous, because oxygen and sulfur are on that same column, they have similar bonding patterns. So an ether is analogous to a sulfide just with sulfur instead of, a sulfide is analogous to ether just with sulfur instead of oxygen. Okay, so then how do we go about the systematic nomenclature here? Remember that the IUPAC names, we referred to these groups as this would be a 1-carbon ether groups, ether substituent, so it was a methoxy. So this would be 1,1-dichloro, 1,1-dichloro-4-methoxycyclohexane. When it's instead the sulfide group, it's a methyl thio group. So not just methoxy, you still keep the YL, and it's a methyl thiol group. And then, just to make things even more of a pain in the butt, for some reason I have no idea, you include that particular substituent in parentheses. Okay, so this, the analogous sulfide would be 1,1-dichloro-4-methylthiocyclohexane. And how do we create these? Similar to what we did before, but instead of using a hydrogen sulfide or a hydrosulfide ion, you use sulfide ion, where that is replaced with a what's called a thiolate ion, where that's replaced with just some generic R group. And then same as before, again, the whole shtick is that these are weak bases, but strong nucleophiles. So they're really favoring substitution type reactions. So this will go and attack and kick off that leaving group, and I'll be left with my sulfide.